Hello guys, this is your host Lucas and you are watching a new episode of the Numberverse. In this video we're going to solve a functional equation. We have f of the quantity 2x minus 1 over x minus 3 equals x squared, and we're going to find f of x. Can you figure it out? Let me know your answer in the comments section. Give this problem a try, and when you're ready just keep watching the video for the solution. Let's do this, but first, if you haven't subscribed us yet, press the subscribe button for more such content. So one of the most typical mistakes when solving these kinds of equations is setting what's on the left-hand side equal to x. So let's go ahead and start with that type of problems. So what happens if you set this equal text, because our goal is to basically make this x, right? So if you do that, you're going to be getting something like 2x minus 1 is equal to x squared minus 3x. From here you're going to be getting a quadratic equation, so on and so forth, but that's not the point. We don't want a numerical value, but we want to be able to express this function where the argument is x instead of this rational expression. So this is definitely not the approach to solve these kinds of problems, and I know that there's been some confusion in a function equation we've done before, so I'm going to try to clear that up as well. So here's what we're going to do. We're going to set 2x minus 1 over x minus 3 equal to another variable. So let's go ahead and use another variable, so let's call this y. And don't ask me, I call this expression y. Okay, now by setting that expression equal to y, of course this has some consequences. We can get x by itself, and this is the idea. I'm setting this whole thing equal to y, because I want to be able to get f of x, but for the time being I'm going to use another variable until I get a nice expression. And then I can replace y with anything I want. Okay. We'll talk about that a little later. So now what happens on the right hand side, since I have x squared, I have to be able to replace x with something. So let's go ahead and solve this in terms of x cross multiply, and then I want to solve for x, so I want to bring the 3y over here and the 2x here. In other words, I'm subtracting 2x from both sides and I'm adding 3y to both sides. Now we can factor out x, and from here I'm able to solve for x, if we divide both sides by y minus 2. Of course I know we have to talk about the domain and range, but as long as these values are appropriate this function is going to be defined. So basically we're talking about a function where it's defined. So from here let's isolate x. It's going to give me 3y minus 1 over y minus 2. So our original expression, if you remember, it was f of 2x minus 1 over x minus 3 is equal to x squared, right? And I was trying to find f of x here. Now I noticed that by replacing this with y, I'm basically replacing x with this. So let's go ahead and replace x with this on the right hand side. So this is going to be f of y is equal to x squared, but x will be replaced with 3y minus 1 over y minus 2. And of course I need to square that. If you square this expression you're going to be getting f of y is equal to 9y squared minus 6y plus 1 over y squared minus 4y plus 4. Now I didn't get f of x. I got f of y, but that's okay. I think this was the confusing part, like how come you replace x plus squares of x plus 1 with t, and then you go ahead and replace t with x. How is that possible? Well, those x's are not the same x's, because I can use any variable I want, right? In a function you can replace this y with t. You can replace y with z, anything you want. You can even replace y with x cubed. Of course there are some limitations. You know, we need to consider the domain and so on and so forth, but as long as they're satisfied you have the freedom. I want to get f of x, so be able to express my function in terms of x, but I have it in terms of y, but no worries, we can just go ahead and replace y with x on both sides. So here's the idea, as long as you're doing it on both sides you're good. Okay, so let's go ahead and replace y with x. And that's going to give us f of x equals 9x squared minus 6x plus 1 divided by x squared minus 4x plus 4. Of course we have to consider the domain here. X cannot equal 2, you know, so on and so forth. For the original problem, if you think about it, the domain is going to limit x equals 3 is not defined, so on and so forth. So those values are going to work together, but you just have to consider those cases. Now I want to say another thing here for this functional equation. We got the answer, but I just want to emphasize one thing here which I believe is important. So what did we do by setting this expression equal to y and solving for x? Well, actually we found the inverse of this function, because this gives us if f of something equals y and you replace x and y, you're basically saying that f inverse of y is equal to x by switching these around, right? So this is kind of like the inverse of our function but expressed in a different variable. So if you already knew that this function here it's a rational function and I can find the inverse of this function, and let me give you a shortcut. So if you have something like ax plus b over cx plus d, and then you're trying to find inverse, you have to change a and d and also make sure that you are switching the coefficients. So d is going to be here as negative dx plus b. And the a is going to come down, but it's just going to become negative a, and this is going to be the inverse of this function. By using that you can safely say that the inverse of this function is going to be 3x minus 1 over x minus 2, which is pretty much what we found here. And this brings us to the end of this video. I hope you liked this video. Thanks for watching. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more such content. If you have any interesting brain teasers or puzzles, you can share with us by fill out a Google form, link is mentioned in the description.